Alright, so good night everyone. Is everyone hearing me? Alright, so good night everyone, welcome to Moyo Math. Of course tonight we are going to do another session to prepare for the exam tomorrow. So we want to ensure that that we are ready, we can enter the exam with confidence and do an excellent paper. Okay? We would have done last night 2022 and tonight we'll probably try to look at one or two more papers. Try to recognize if there are any repeated questions, because if you look at the history of the paper, a number of questions are normally repeated. So in going through the process, we'll see if we can recognize any repeated questions and keep those questions in mind. So if we do see it in the exam, we can quickly shade and move on to the next. Okay? But it's also important for us to know how to work out some of these questions. Just in case they do not bring any repeated questions, or if they do make minor changes, we're able to now execute well. So what I'm going to do tonight I'm going to start with June 2020. Now, this is an important exam paper. The issue with this paper is the quality of the paper. The paper I got, the quality of the paper is not 100%. So some of the words may be a bit blurred, but I will try to state what is the text when we do get a question where it's challenging to see what is written, all right, or what is stated. So as you can see from the first, right, so the text is a bit blurred. So, question 1, it says express. So, let's look at question 1. Question 1 says, so this is from June 2020. It says the expression AB plus 3C minus 3B minus AC is equal to. So we have these options here. We can easily take each option, expand it to get what we have there, or if not, we can carry out our method of factorization. We can factorize that expression to get one of the options shown. So to factorize, what I'm going to do is to use the method of grouping. So I'm going to divide these four terms into two pairs. Or if not, what I'm going to do, if we look clearly, we have nothing common to these two terms. We have nothing common to these two terms. So what I'm going to do is rearrange where I'm going to have a common factor to each of my pairs. So I'm going to put AB and minus AC together. I'm also going to put negative 3B and plus 3C together. And I've written negative 3B and plus 3C because I want the same order, BC, BC. So let me now factorize. I'm going to pull out A, which is common. And I'm going to divide A into AB to give me B. I'm going to divide A into negative AC to give me negative C. Let me factorize my second pair. So I normally draw a dotted line to separate my pairs. The sign controlling the first term of the second pair, I put down my sign, or I put it as part of the highest common factor automatically. What else is common? 3. So negative 3 becomes my highest common factor. And let me divide negative 3 now into each term. So negative 3 into negative 3b will give me b. And negative 3 into plus 3c will give me negative c. I can further factorize because I recognize I have the same thing in brackets. So let me further factorize. So I put out b minus c and as my common factor, and what remains, a minus 3, goes in the other bracket. So for question 1, it's b minus c and a minus 3. So for question 1, the answer there is D. So question 1D. Let's move on to question 2. So question 2. So question 2 of 2020 states, and this here is a repeat. So questions that are repeated, you're going to see repeat stated. So we have here question 2, 1 all over x plus 3. So it's very likely that you can see this if you were on the live last night when we did 2022. This also came plus 3 over x squared minus 9. So just to recap how we treat with such, we're going to express this as 1 over x plus 3 all over. I can factorize x squared minus 9 by using the method of the difference of two perfect squares. So this is x plus 3, x minus 3 when I factorize it. I am going to find the LCM. The LCM will be 1 of each. So I have 2x plus 3s and I have 1x minus 3. So I'm taking 1 of each. So it's going to be x plus 3, x minus 3. I divide x plus 3 into my LCM to get x minus 3. I'm going to multiply x minus 3 by 1 to give me x minus 3. Bring down my addition sign and let me divide the denominator into the LCM. So when I divide x plus 3, x minus 3 into itself, I'm going to get 1, and 1 by 3 gives me 3. Of course, I can simplify the numerator. I have here negative 3 and positive 3, which obviously becomes 0. It leaves me with x. And in my denominator, I can expand the denominator. X by x gives me x squared. X by negative 3x. Plus 3 by x is plus 3x. And plus 3 by negative 3 is negative 9, which then simplifies to become x all over. Negative 3 and negative 3x and positive 3x will cancel out to become 0. So I'm going to get x over x squared minus 9. So for question 2, the answer there is B. And this here is a repeat, right? It is a repeated question. Let's move on to question 3. So make sure we be conscious of those questions that are repeated. Question 3. We have here, given that f of x, so again the text may not be as clear, so I'll write it down, the actual function in this case, so we can recognize what are the terms of the function. Given that f of x is equal to 1 minus 4x minus 2x squared, then f of x can be expressed in the form. So if you look at the form given, that is in the form a into x plus h all squared plus k. So it requires us to complete the square and of course state it in that form. So what we can do, we can rearrange, we can write f of x is equal to negative 2x squared minus 4x plus 1. And to complete the square, we always identify what is a, which in this case is negative 2, b which is negative 4, c which is 1. And we know when we are completing the square, h is formed by using the formula b over 2a. We know b will be negative 4 over 2 times a, which is negative 2. So negative 4 and 2 by negative 2 is negative 4, so we're going to get positive 1. So we know h will be 1, and this will be, of course, to find k, 4ac minus b squared over 4a. This becomes 4. I replace a with negative 2 in brackets. I replace c with 1 in brackets. Subtract, I'm going to replace b with negative 4 in brackets all squared. All over 4 times I replace a with negative 2. So when I simplify that, let's see what we're going to get. 4 by negative 2 is negative 8. Negative 8 by 1 is negative 8. Subtract negative 4 all squared will be 16. All over 4 by negative 2 will be negative 8 in my denominator. So I'm going to get negative 8 subtract 16, which is negative 24. And negative 24 divided by negative 8 will give me positive 3. So I have found my a, my h and my k. So let me just write it in the form quickly. This will be negative 2 open brackets is going to be x. I'm going to replace h with plus 1 in brackets all squared, and I'm going to replace k with plus 3. But if we look at the options, we don't have the options stated, any of the options stated in that form, so we can rearrange the terms so we can get exactly what we want in the options. So what I'm going to do, I'm going to take this positive 3 and I'm going to put it in front of the negative 2 into x plus 1 all squared. So this will be written as 3 minus 2 into x plus 1 all squared. Alright, whose answer for question 3 is C. So let's move on to question 4. So question 4, we have here, let's see what we have for question 4. Right, so I think we would have done this question last night in 2022 as well. Again, completing the square like what we just did for question 3. So we have 4, this is x squared minus 6x plus 13. And we want that to be expressed in the form a into x plus h all squared plus k. So again, the same process. We let a be 1, b be negative 6, c be 13. So just in case you don't see a repeat and they ask you to complete the square, you know what to do. So we know a, b and c is stated. H is b over 2a, which will be negative 6 all over 2 times 1. Negative 6 over 2 is negative 3. So we know h will be negative 3. And we know k will be found by using 4ac minus b squared over 4a. So this becomes 4. Replace a with 1, c with 13. Subtract b, which is negative 6 in brackets all squared, over 4 times replace a with 1. So we're going to get 4 by 1 is 4, 4 by 13 will give us 52. Subtract negative 6 squared is 36 all over 4. And 36 from 52 will give us 16. And 16 over 4 is 4. So we would have done this question, the same question last night. So this is a repeat, so I should have repeat stated. So k is equal to 4. So we know a is 1. We know h is negative 3 and we know k is 4. So for question 4, the answer there is B. So let's move on now to question 5. So we have, right, so the quadratic equation is such that that should be sum of its roots is negative 2/3 and the product of its roots is 3/4. The quadratic equation is, so when we deal with roots, we're talking about sum of roots, product of roots. This will fall under roots involving alpha and beta. So when it comes to finding the quadratic equation for roots involving alpha and beta, we just need to know the standard equation, which is it's x squared minus the sum of roots times x plus the product of roots is equal to 0. So once you know that standard formula, then let us substitute what is given. So it says here the sum of the roots is negative 2/3. So this is x squared minus the sum of my roots is negative 2/3. So I'm going to put negative 2/3 in brackets times x plus the product of the roots is 3/4. So I'm going to put 3/4 is equal to 0. And let me simplify that to see if I get one of the options shown. So this will be x squared. A minus by a minus is a plus. So this is positive 2/3 x plus 3/4 is equal to 0. And what I want to do now is to remove this equation from its fraction. So to remove it from its fraction, because if you look, the equation is not in fraction, the options are not in fractional form. So I'm going to put x squared over 1, find the LCM of all the numbers in the denominator, which is the LCM of 1, 3, and 4 is 12. multiply x squared by 12, multiply 2/3 x by 12, multiply 3/4 by 12. So 12 by x squared gives me 12x squared. 2/3 x by 12 will be 3 to 12, 4 by 2x will be 8x, plus 3/4 by 12, 4 into 12, 3 by 3 is 9, and I'm also going to multiply 12 by 0. So 0 by 12 will also give me 0, right? So therefore, this is my equation in the non-fractional form, and therefore, the equation we're looking at is option A. So for question 5, the answer is A. Alright, let's move on to question 6. So June 2020. So don't forget, those who are online presently, don't forget to like, share, and subscribe. Okay, and be a part of to get all the material that Moyo Math will be sharing on a regular basis. Okay, so question 6, we have the set of values of x for which 3x plus 2, so 3x plus 2 is greater than x minus 2 is. So they want us to determine the set of values of x. So this is a simple inequality. So to solve that inequality, what are we going to do? I'm going to bring all my x's on the left of the inequality symbol. So it's 3x minus x is greater than, of course all numbers will go on the right of the inequality symbol, negative 2. So positive 2 comes across as negative 2. So 3x minus x is 2x is greater than negative 4. And therefore to get x by itself, I divide both sides by 2. X is greater than negative 2. So the answer for question 6 will be D. So question 6 is D. So let's move on to question 7. So question 7. Right, so this here is a repeat as well. So I think we would have done this in 2022. So this is another repeat. So a question you need to be conscious of. So this will be 3x minus 2 over 2x plus 1, otherwise known as a rational inequality, is less than or equal to 0. Remember, we treat with a rational inequality. So if you see one in your exam tomorrow, you know how to treat with it. We're going to multiply both sides of this inequality by the square of the denominator. So whatever is in your denominator, which is x, 2x plus 1, I'm going to multiply this side by 2x plus 1 in brackets squared. And what I do to one side, I do to the other. I multiply 0 by 2x plus 1 in brackets squared. And of course, what's going to happen here, I'm going to divide 2x plus 1 into 2x plus 1 all squared to give me 2x plus 1. And I'm going to multiply 2x plus 1 by 3x minus 2 is less than or equal to 0 by 2x plus 1 all squared is 0. This here now is a quadratic inequality. So with all quadratic inequalities, you need to get the roots first, which are very important. So to get the roots, you let 2x plus 1, 3x minus 2 be equal to 0. And we are going to use our keywords either 2x plus 1 is equal to 0, 2x is equal to negative 1, x is negative a half, which is 1 root, or we're going to let 3x minus 2 be equal to 0, 3x is equal to positive 2, x is equal to 2/3. So that there is my other root. And remember, with quadratic inequalities, you must show a sketch to help you to find the range of values. And if you expand these two binomials, you're going to get a quadratic expression on the left of the inequality symbol, whose number in front of x squared is positive, which will indicate us that our curve is a what? Curve that's concave up. The roots are what? Negative a half, which will be placed on the left, because it's less than 2/3, 2/3 on the right. Of course, I have my two roots. It's less than or equal to, so I shade them. And what less than or equal to will tell us. It means we are looking at the region below the x-axis. That's where our range of values will lie. Good? So it's below the x-axis, So the region below the x-axis is the belly. I like to call it the belly of the curve. So we're looking at here. So that's where our range of values that will satisfy the inequality will lie. So how do I state my answer? I'm going to state here this is x. I'm going to put x is greater than or equal to minus a half, and so when it falls within the belly we use the word and. X is less than or equal to 2/3. So sometimes you see the answer expressed like this, but when it falls within the belly, you can collate or bring them together. And let's see how they have the, and well, we have the answer collated. So this will be what? When we collate, we leave the inequality on the right as is. And if x is greater than or equal to negative a half, it also means negative a half is less than or equal to x. So that's a collated. So the inequality that of course will correspond to what we have here, negative a half is less than x, which is less than or equal to 2/3. So the answer for 7 is C, which is a repeat. Good? Let's move on to question 8. So 8. We have here, if f of x is equal to negative 2/9x, I think that's x cubed, right? Then what is, for negative 3 less than or equal to x, less than or equal to 3, what I want us to do is to determine what is the range. Okay, so we have, for question 8, f of x is equal to negative 2/9x cubed for negative 3 less than or equal to x less than or equal to 3. Good? So we want to determine what is the range. We have the domain. This is the domain from the lowest to the highest value along the x-axis, and we want to determine what's the range, lowest to the highest value along the y-axis. So negative 3 will correspond to what? So to find that, we are going to substitute negative 3 into the function. So this will be negative 2/9 times negative 3 all cube. Negative 2/9, negative 3 all cube will give us negative 27. And negative 27 by negative 2/9, this will be 9 into 9 is 1. 9 into negative 27 is negative 3. And negative 2 by negative 3 will give us positive 6. And now let's divide. So you know negative 3 is linked to positive 6. And 3 now, I'm going to substitute 3 into the function. Negative 2/9 times 3 cubed will be negative 2/9 times 27. So this is what? 9 into 27 will give us 3. And 3 by negative 2 is negative 6. Good? So we're going to have 3 being linked to negative 6. And negative 3 being linked to 6. So this is what we're going to be basically looking at. If you have 3, you have negative 3, right? So you're going to have 3 being linked to negative 6. So this is along the y-axis, the f of x or y-axis, and you're going to have negative 3 being linked to 6. So therefore the lowest to highest value along the y-axis, we're going to write it as negative 6 is less than or equal to f of x. F of x means y, which is less than or equal to 6. So our answer there, negative 6 is less than or equal to f of x, which is less than or equal to 6. So question 8, our answer. So we have here negative 3 is linked to, right, so this is negative 2/9, that's linked to 6. And then we have negative 2/9, 27, negative 6, yeah? So answer here, of course, will be C, sorry. So we can have C, yeah? Negative 6 is less than or equal to f of x, which is less than or equal to 6, lying within that range, okay? Okay, let's move on now to question 9. So question 9, we have here a function is defined by f is such that x is mapped onto x plus, I think that's 1 all over x plus 1. The quality of this exam paper was terrible. I think that's x plus 1 squared in brackets squared. I believe so. Let's see, x plus 1. Or if that is just a mark there, I'm not sure. Right? But let's see what we're going to get. If it's, I'm going to put it as 1 all over x plus 1. So what are we going to do? To find the, that is f inverse of 1, to find f to the power of negative 1, 1 in brackets, what do? We are going to carry out 3 important steps. So the steps are, we're going to let y be equal to 1 over x plus 1. My second step is to interchange x and y. So where I see y, I'm putting x. Where I see x, I'm going to put y. And then my final step is to make y the subject of the formula. So to do so, I must remove this from its fractional form. This is x over 1. And what I can do to remove it from the fractional form is cross multiply. So I'm going to multiply x by y plus 1. And I'm going to multiply 1 by 1. So if I'm making y the subject, I can move, if you want, you can remove your brackets if you want, or you can remove x first. I'll go removing brackets, xy plus x is equal to 1. And now I'm going to subtract x from both sides. I'm going to get xy is equal to 1 minus x. And therefore to get y by itself, it becomes 1 minus x over x. Good? And they want us to determine what is the value of f inverse of 1. What we have found here is f inverse of x, which is 1 minus x over x. So therefore f inverse of 1 will be 1 minus 1 over 1. 1 minus 1 is 0, and 0 over 1 is the same as 0. Alright? So the answer for f inverse of 1 will be 0, whose answer is A. Let's move on to question 10. So 10, summation. So question 10 states, we have here, so let's see, the functions f and g are defined by f is such that, this is question 10, f is such that x is mapped onto 2x minus 5, and g is such that x is mapped onto 4 plus 3 over x. They want us to find the composite function. You know what's composite function? You bring them together, you combine them. Gf of x. Good? So to find gf of x or g of f as they have stated there, then it means we're going to take the function on the right, which is f of x, and we're going to substitute it into the function on the left, which is g of x. So I'm going to take the entire expression for f of x, and I'm going to substitute it into my expression for g of x. So where I see x, I'm going to replace it with 2x minus 5. So this becomes 4 plus 3 all over 2x minus 5. And of course, we're not seeing that option there, but what it will encourage us to do now is to simplify. So I'm going to put 4 over 1, find my LCM. The LCM of 1 and 2x minus 5 is 2x minus 5. I'm going to divide 1 into 2x minus 5, which is 2x minus 5. And I'm going to multiply 2x minus 5 by 4, which gives me 4 into 2x minus 5. Plus, let me divide 2x minus 5 into itself will give me 1. 1 by 3 will give me 3. And let me now simplify my numerator by removing brackets. 4 by 2x is 8x, 4 by negative 5 is negative 20, plus 3 all over 2x minus 5. And in my numerator, I can simplify it further. I can say 8x and negative 20 plus 3 gives me negative 17 all over 2x minus 5. And let's see if we have that as our option. Yes, the option is C. So the composite function is C. So let's move on to question 11. So question 11. We have here, which of the following graphs depicts a function? Right? So a function, of course, is 1-to-1 or many-to-1. Right? Those types of mappings are considered functions. So A will be a function because this is many-to-1. We're going to have here many elements of the domain coming from the x. This is range y. Many elements of the domain will be mapped onto one element of the codomain. So this is mapped onto the same element of the codomain, of the range. So many elements of the domain is mapped onto one of the range. So therefore it's many to one, and therefore many to one is a function. So the answer for question 11 is E. All the others will not be functions. Yeah? So let's move on to question 12. So I'm going to write here many to one function. So question 12. Let's look at 12. Right, so this is a repeat. So you see repeat. So this is a repeated question. So let's make sure we be conscious of this. It's possible you can see this as well in your exam tomorrow. So 12, we have, and we would have looked at this last night too, I think, yeah, when we in 2022. The square root of 5 minus 1 all over 1 plus the square root of 5. Remember we have surds here and we never work with surds in the denominator. Surd in the denominator is square root of 5. So to remove it, we have to now rationalize by multiplying this fraction by another fraction whose numerator and denominator will be the conjugate of this denominator. And what's the conjugate of 1 plus the square root of 5? It's 1 minus the square root of 5, which I write in the numerator of that fraction. And I also write 1 minus the square root of 5 in the denominator of that fraction. And what I'm going to do is, of course, multiply my numerators, multiply my denominators, and simplify to see if I get one of the options there. So this is what? The square root of 5 minus 1 by 1 minus the square root of 5 over 1 plus the square root of 5 by 1 minus the square root of 5. So let me expand the square root of 5 by 1 is the square root of 5. The square root of 5 by negative the square root of 5 is negative the square root of 25, which is 5. Negative 1 by 1 is negative 1. Negative 1 by negative the square root of 5 is positive the square root of 5. All over, let me expand the denominator. 1 by 1 is 1. 1 by negative the square root of 5 is negative the square root of 5. Positive the square root of 5 by 1 is positive the square root of 5. And positive the square root of 5 by negative the square root of 5 is negative the square root of 25, which is 5. And of course, I'm going to simplify both numerator and denominator. My like terms are the square root of 5. I have like surds, so I can add them. The square root of 5 plus the square root of 5 is 2. The square root of 5 and negative 5 subtract 1 is negative 6. All over, let me simplify my denominator. Of course, my negative the square root of 5 and positive the square root of 5 will become 0. And I'm going to be left with 1 minus 5, which is negative 4. Alright, and in doing this question, we were doing this last night, in order for us to get one of the options there, because a bit of factorization will have to take place. If we factorize it as is, we're going to have a negative factor, negative highest common factor, which we do not have in any of our options there. So, to make sure that we get a positive highest common factor, what we're going to do is rearrange the numerator. So I'm going to write it as negative 6 plus 2 to the square root of 5 all over negative 4. Yeah? And now I'm going to factorize the numerator, and once there is a negative sign or any sign that controls the first term, if it's negative or positive, it's automatically a part of the highest common factor. So the negative sign is automatically a part. What is common to 6 and plus 2 to the square root of 5? Clearly 2. So negative 2 becomes my highest common factor, which I'm going to divide into each term. Negative 2 into negative 6 is positive 3. And negative 2 into plus the square root of 2 to the square root of 5 will give me negative the square root of 5. All over negative 4. And therefore I can simplify. I can say negative 2 into itself is 1. And negative 2 into negative 4 is positive 2. So we'll end up with here half into 3 minus the square root of 5. Yeah, whose answer for question 12 is D. Alright, so remember this is a repeated question, so make sure you know you're familiar with this question, alright? So I'm going to move on to question 13. And this here is also a repeat. So again, it's highly possible you can see this in your exam tomorrow also, right? So if you see it in your exam, all you do is shade and you move on. So, but just in case they bring a question with, you know, some minor changes, you know how to treat with it, right? So question 13, we have the value of 2 to the power of z, where z is equal to 5 plus log 3 to the base 2 is. So we want to determine what is 2 to the power of z, and the trick with this is logs, so it means the trick with this, we want to get each term to a base of 2. This is to a base of 2. So to get z to a base of 2, we're going to write it as z log 2 to base 2 because of this lower log a to base a, which always means 1. 5 is the same as 5 log 2 to base 2 because log 2 to base 2 is 1. 1 by 5 gives me 5, but it's now to a base of 2 plus log 3 to base 2. I'm going to apply now what I call my power law. So I'm going to take this z and represent it as the power of this 2 here. It becomes log 2 to the power of z to base 2. I'm going to do the same here. I'm going to bring this 5 and represent that as the power of 2. So this becomes log 2 to the power of 5 to base 2 plus log 3 to base 2. Now, when solving questions involving logs, your aim is to get single log functions on either side. One log function on the left, one log function on the right. Now, when you have one log function on the left, so that stays as is. Let me express log 2 to the power of 5 as log 32 to the base 2 plus log 3 to the base 2. So let me get one log function on the right by applying now what we call the product law. Once we're adding, what we have to do is multiply the two arguments. You call them arguments. So this becomes log 32 by 3 is 96 to base 2. So now that you have one log function on the left, one log function on the right, what you can do is simply equate the arguments. For these two arguments, you call them arguments, just put them together. Drop the log 2. So you're going to get 2 to the power of z is equal to 96. So when they ask the value of 2 to the power of z, it's simply c, which is 96. Remember, that's a repeat. Okay? So let's look at question 14. So remember, this is June 2020. You know, we're going through each question, making sure that, you know, we clear how to treat the things, and let's make sure we can enter that exam comfortably tomorrow and do a good paper, right? So question 14. We have given that log x cubed to base 2 is equal to 6, then the value of x is, remember the text in this paper was terrible, right? This is the best I could have gotten. So, so let's show you this. So to find x, what we can do is to move this from logarithmic form. This is a logarithmic equation to exponential form. So to move it to exponential form, I'm going to move this 2 from the base of the log to the base to become the base of 6. So this becomes, and I'm going to drop log after that. So this becomes x cubed is equal to 2 to the power of 6. Yeah? The aim is to find x. So to find x, what are we going to do? This becomes x cubed. 2 to the power of 6 is 64. And therefore, to find x, x will be equal to, we find the cube root of both sides. So the cube root of x cubed, that becomes x. And the cube root of 64 will be 4. Whose answer for question 14 is B. So let's look at question 15. Question 15 we have, right, this is also a repeat. I think we would have done this last night also. Good? Which of the following so if you see it, you know what to do, right? Which of the following mathematical statements are true? Again, we know the law of logarithms, which we just looked at in the last question, of the product. Suppose to be addition in the middle there, not multiplication. This is the quotient, the dividend, which will be subtraction, and this here is the power law. This is b, which is by the power of p here, which will come in front of the log function to become b log p to base, I think that's base e. So the two that are right here will be 2 and 3, whose answer is C. So 2 and 3 will be the answer, right? Whose answer there is C. So let me put that in red. Alright, let's look at question 16. So 16, we have right, that is 3 to the power 3 multiplied by 27 to the power of 2x is equal to 9 to the power of x. Right? So we want to solve x, so that is an equation in exponential form. So again, what we want to do is first make sure we get all terms to a base of 3. So this becomes 3 multiplied by 27 is 3 cubed, all to the power of 2x. 9 is the same as 3 squared, all to the power of x. So this becomes 3 times 3 to the power 3 by 2x will be 6x is equal to 3 to the power of 2x. Let me try to get single terms of the same base. One term of base 3 on the left, one term of base 3 on the right. I have one term of base 3 on the right already. So they get this as one term of base 3. This 3 has a power of 1, which is understood, and we are applying our law of multiplication of indices. So 3 stays, and we add the powers. 1 plus 6x is equal to 3 to the power of 2x. Once we have single terms of the same base on either side of the equal sign, we can simply equate the powers. 1 plus 6x is equal to 2x. And now let's solve x. So this will be 6x, positive 2x will come across as negative 2x, plus 1 goes across to the right as negative 1. I'm going to get 4x is equal to negative 1, and I divide both sides by 4 to get x as negative a quarter. Question 16 is B. Yeah? Alright, let's look at question 17. So question 17. We have here, right, so this here is also a repeat, yeah? So I think we would have done this last night as well too. The sum of the first n terms of a geometric series is, so this is the sum, that's 4 to the power of n minus 1. So they want us to determine for the series which one is applicable. Good? Now if that represents the sum, now if I have n as 1, so normally when you have that subscript, we start with 1, 2, 3, go up the root. So if n is 1, so when n is 1, we're going to get s subscript 1 will be, which is the sum of my first term, the only term, first term is 4 to the power of 1 minus 1, which is 3. Yeah? Now what is my second term? Or the sum of the first two terms, right, will give me what? The sum of the first two terms will give me 4 times 2 minus 1. 16 minus 1 is 15. Yeah? So I know that if the sum of my first two terms is 15, then what must I add to 3 to give me 15? The sum of my first two terms give me 15. So what must I add to 3 to give me 15? It has to be 12. So 3 is your first term, obviously, because the sum of the first term, if 3 is the only term, then 3, the sum will be 3. So you have 3, which is the first. So when we add 12 to the first, it's going to give us the sum of the second. And what will be the sum of the third? So this is 4 times 4 to the power of 3 minus 1, which is 64 minus 1, which is what? 63. So therefore, to find the sum of my third term, then what am I going to add to 15? That will give me what? 63. And it has to be what? 48. So I know that the first 3 terms, you have the first 3 terms, 3 is 1, the second term is 12, the third term is 48 is right. So this is right. So we have 3, 12 and 48, which are your 3 terms. And if it's a geometric progression, then to move from 3 to 12 to 40, we need the common ratio, a common constant. So clearly, the common ratio there cannot be -1, because to move from 3 to 12 to 48, we know it has to be, we have to multiply 3 by 4 and 12 by 4. 3 by 4 gives 12, 12 by 4 gives 48. So we know the common ratio can never be -1. So this is out. And let's see if the last is applicable to the sum, the expression given for the sum there. So if we have s to the power of n is equal to 4 to the power of n minus 1, s to the power of n equal to 4 to the power of n minus 1 can be rewritten as s to the power of n is equal to 2 to the power of 2 in brackets all raised to the power of n. And this can be written as s to the power of n is equal to 2 to the power of 2n minus 1. So therefore, if s to the n can be rewritten in that form, then s to the 2n will simply mean I can now replace n with 2n. So I'm going to write 2 to the power of 2 times 2n minus 1. So s to the 2n will give me that. And therefore, s to the 2n will be 2 to the power of 4n minus 1. Yeah? So when I have 2n as my subscript, this is what I'm going to get, which is what I have there as 3. So it means that the options 2 and 3 satisfies the sum given. So it means the answer here will be C, which is a repeat. Good? So make sure you be conscious of this. You can see this in your exam tomorrow, you know what to do to see. But again, look carefully, sometimes they rearrange the options, right? So even though I've written C and it's 2 and 3. So you're looking out for 2 and 3, not C. So let's look at 18. So 18 states or like I left out okay, like I would have left out 18, so 18 and 19. Alright, anyway, let's move on to 20. Alright? Yeah? So we created the PowerPoint, I would have left out 18 and 19, but that's okay. Let's jump to 20. Alright, so 20 the sum of the odd integers between 10 and 50 is. So you want the sum of odd integers between 10 and 50, sum. So, and this is a question that I would have seen in past years also, so make sure you understand it. So the sum of odd integers will be, if it's an odd number is a number that cannot be exactly divisible by 2. So your odd numbers obviously will be, you're looking at 11, 13, 15, 17 and so on. And the odd number before 50 will be 49. Yeah? So if they want us now, of course, we recognize the odd numbers between 10 and 50, of course, going all the way up to 49, and we put some dots here. So we can recognize that to move from 11 to 13, I must add 2, from 13 to 15, and I keep adding 2, which will indicate that this is an arithmetic series, an arithmetic progression. So for an arithmetic progression, if we want to find the sum of odd numbers between 10 and 50, the sum, we know the formula for the sum to n terms of an AP is n over 2 into 2a plus n minus 1d. So in order for us to find the sum, we need obviously to know what's the first term. The first term is 11. We need to know as well what is the common difference. The common difference will be 2. 11 from 13, 13 to 15, the common difference is 2. But we also need to determine the number of terms. Right? So how many odd numbers exist between 10 and 50, which we don't know. So to find that, this is what we're going to do. We know that the last odd number before 50 is 49. So we're going to take here 49 is equal to a plus n minus 1d. Yeah? So the formula used to find the value of a given term. And therefore, we can find n. 49 is equal to, again, a is, and let me just simply state this, a is 11, d is equal to 2, so this will be 11 plus n minus 1 times 2, this becomes 49, is equal to 11, let's remove the brackets, plus 2n minus 2, this becomes 49, 11 minus 2 is 9 plus 2n, and what I'm going to do is to subtract 9 from both sides, becomes 49 minus 9 is equal to 2n, and of course 9 from 49 will give me 40 is equal to 2n, and I can divide both sides by 2, so 40 divided by 2, n is what? 20. So I know the number of odd numbers between 10 and 50 will be 20 odd numbers, right? So I want to find the sum to 20 odd numbers. So to find the sum, again, this is my formula I'm using. So let's see what the sum will be to 20 odd numbers. S is equal to, S subscript 20, meaning 20 odd numbers, is equal to 20 all over 2 into 2 times A, which is 11, plus 20 minus 1, which is 19, times D, which is 2. So we're going to get S subscript 20, sum, which means sums to 20 terms. 2 into 20 is 10. This is 2 by 11, which is 22. 19 by 2 will give us 38. 38 plus 20 will give me 60. And 60 by 10 will give me 600. So the sum to 20 terms, which of course represents sum of odd numbers between 10 and 50, will be 600. Whose answer for question 20 is me. Alright? So let's move on now to 21. Oh, and don't forget, well, those who are on, just to note, your math exam, it is next week Tuesday, and I'm having something very special for students who are writing the math exam next week. It's called the Must Pass Moyo Math course, right? So I, will strongly suggest that you come be a part of it. All the information will be shared very soon. By tomorrow, all the information will be shared. So stay tuned, right? Must pass. It's going to certainly help you to be fully ready and prepared. Yeah, to pass that math exam. Because remember, everything is based on that paper 1, and we want to try to get full marks in that exam paper. Alright? So, must pass Moyo Math course. Okay? Alright, so looking at 21. So 21, we have here, right, and this is a repeat. I think I would have done this last night also. The coordinates in 2022, so most of these questions, you know, were in 2022. So again, it can be in 2023. So we have the equation x minus 1 all squared plus y plus 3 all squared is equal to 36. So the equation of a circle, what they want us to do is determine the coordinates of the center. So we have the equation of the circle in the general form. So what we can do in the general form, if you have a circle center and if the center has positive coordinates h and k, now we can have sometimes you see the equation of the circle where the center, the coordinates are negative. Alright, if you have positive coordinates of the center, the general form will be x minus h in brackets all squared plus y minus k in brackets all squared is equal to r squared. So we want this equation just to mimic what we have here, the general form. So this will be x minus 1 in brackets all squared. So I have my x, I have my negative sign, no h automatically is 1, plus y, this is y plus 3, so I'm going to write it as y, rewrite it as y minus 3 in brackets all squared is equal to your 36, good, which corresponds to r squared. The center will be C, 1, negative 3. So 21 is C. Let's look at 22. Again, a repeat. You see, this is also a repeat. So make sure we be conscious of those questions that are repeated. So if you see it, you just shade one time. And we would have done this last night, and it required some work, but let's do it, yeah? So we have a 22, you have a circle, you have a line passing through it, and they want the coordinates of the points of intersection where the line and the circle meet. They meet where? Here and here. And when you have a linear and non-linear, the non-linear is the equation of the circle, linear is the line, you know you have to solve them simultaneously to get the coordinates of the 2 points of intersection. So we're going to take x squared plus y squared is equal to 10, y minus x is equal to, so y minus x minus 2 is equal to 0. I'm going to know it's only the method of substitution we're going to use here. So I'm going to make y the subject. This negative x comes across as positive x, negative 2, positive 2. Call that equation 3. So this is equation 1, equation 2. Substitute equation 3 into equation 1. So where I see y in that equation, I'm going to replace it with x plus 2 in brackets squared is equal to 10. I'm going to expand. This becomes x squared plus x plus 2 by x plus 2 is equal to 10. This becomes x squared. When I expand, x by x is x squared, x by plus 2 is plus 2x, plus 2 by x is plus 2x, plus 2 by plus 2 is plus 4 is equal to 10. Let me simplify. I'm going to get what? 2x squared plus 4x plus 10 comes across as negative 10, so it's going to be 4 minus 10 is equal to 0. Becomes 2x squared plus 4x minus 6 is equal to 0. That is a quadratic equation. When you solve them simultaneously, linear and non-linear, you must get a quadratic, right? Substitution method, quadratic equation. Let me simplify that quadratic equation by dividing each term by 2. So I'm going to get 2 into 2x squared is x squared. 2 into plus 4x will be plus 2x. And 2 into negative 6 is negative 3. 2 into 0 is 0. So let me factorize the expression on the left. This is 1 by negative 3 is negative 3, and I want two factors of negative 3 that can help me to get the middle term plus 2x. And that will be what? That will be 3 by negative 1. So I'm going to get 3x and negative 1x will help me to get my middle term 2x. So I'm going to rewrite this equation as x squared plus 3x minus x minus 3 is equal to 0. I'm going to pay off So I can factorize what is on the left of the equal sign. I pull out x. I'm going to get x plus 3. Bring down my negative sign. There's nothing common to x and 3, but 1 is understood after that negative sign. So negative 1 into negative x is x. Negative 1 into negative 3 is positive 3 is equal to 0. I have something common, so I can further rewrite. I can further write this, further factorize as x plus 3. X minus 1 is equal to 0, and now I can use my keywords either x plus 3 is equal to 0, x is negative 3, or x minus 1 is equal to 0, x is 1. Alright, so those are my two values of x where the line and the curve meet. But I have to get the values of y, so all I'm going to do is substitute each value of x into equation 3 to find y. So I'm going to substitute x equal to negative 3 into equation 3. So we're going to get what? Y is equal to negative 3 plus 2. Y is negative 1. So one point of intersection will be x negative 3, y negative 1. Good? And then we're going to substitute x equal to 1 into equation 3. So this becomes y is equal to 1 plus 2, y is 3. So the second point of intersection will be 1, 3. So your 2 points of intersection with the line cuts or intersect the circle at 2 points will be negative 3, 1, 1, 3, whose answer is D. Okay? And what you could have done to make this easier, instead of going through all this working, just trial and error, right? That's trial and error, which will take some time in the exam. So you're going to take each one of the points and their coordinates and you substitute it into each equation. So if you replace y with negative 1 and x with negative 3 and you subtract, you work it out and you subtract 2, you're supposed to get 0. Similarly, when you substitute x as negative 3, y as negative 1 and you work it out, you're supposed to get 10. And then you do the same thing for 1, 3. So you must also get 0 when you substitute and 10 when you substitute. So then you know automatically those are the coordinates. Good? So even easier way to get the answer. But of course, for beyond CSEC purposes, let's make sure we know to solve simultaneously on linear and non-linear. Alright? So let's move on to 23. So 23, we have, right, so the line y equal to 2x minus 7 and the line x plus y equal to 7 intersect at the point. So again, simple simultaneous of our pair of linear this time. Good? And we can do the same thing again, trial and error, take the points and substitute them and we must get some equality relationship going on, right? But if you have to solve simultaneously, we have y is equal to 2x minus 7 and we have x plus 3y is equal to 7. You can solve a pair of linear using elimination or substitution. I'm going with substitution because y is the subject one time. So I'm going to substitute this expression 2x minus 7 into this equation. So I'm going to get substitute 1 into 2. I'm going to get x plus 3. I'm replacing y with 2x minus 7 is equal to 7. I'm going to get x plus, remove brackets, 6x minus 21 is equal to 7. I'm going to get 7x minus 21 is equal to 7. 7x is equal to 7 plus 21. 7x is equal to 28. And divide 28 by 7. X is 4. Having found x, let's find y. So I'm going to substitute x equal to 4. I'll put it into equation 1. So we're going to get what? Y is equal to 2 times 4 minus 7. Y is equal to 8 minus 7. Y is 1. So the coordinates we should have gotten for that line, but the two lines meet, will be 4, 1. whose coordinates 23 will be A. So 23A. Let's move on to 24. Again, another repeat. Repeat. If you see it in the exam, again, just make sure it's the exact question, read it properly, and make sure that the options, don't look at A, B, C, make sure it's the correct option, right? So let's see what's the answer for this one. So, 24. So again, last time we would have done this question. It says here for 24, vector question, by the way. A vector, the vectors I and j represent 1 kilometer per hour east and north respectively. Right? So I represents 1 kilometer east, j represents 1 kilometer north. Right? So you know the magnitudes of your vectors can be represented in terms of I and j. A man sails a boat on a lake such that the velocity is negative I plus 2j when there is no current. So there is no current, the boat is sailing nicely. If there is a current, 3I, then the resultant vector v is given by what? If there is a current, then of course the boat will shift in a particular direction. So let's see. So we have here, and it's good to have that visual. So we're going to have here, and if we have negative I plus 2j. Negative I plus 2j is the same as negative 1. You can write it as negative 1, 2. And negative 3i, that's negative 3i plus 0j. Yeah? Is it negative 3 or just, it's 3i, sorry. 3i plus 0j, and we can write it as 3, 0. So, let's show those two vector quantities, the magnitudes on this Cartesian plane. So, this is a position vector starting at 0. Negative 1, 2 means you're going to move negative 1 to the left and 2 upwards. So this is 1, 2, 3, negative 1, negative 2, negative 3. I'm moving negative 1 to the left and 1, 2, 2 upwards. So this is the movement of the boat. The boat is sailing in that direction where there is no current. But then what happened? Then the boat experiences a current, right? So, and the current is what? 3I. So obviously the direction will change. Look at 3I, which is the same as 3, 0. 3, 0 means you have, 0 means you have no vertical movement. 3 means you only have horizontal movement. So you're going to move 3 to the right. 1, 2, 3. So this is the boat moving in that direction. Good? That's the direction the boat is moving. They want us to determine what is the resultant vector. So you see this vector here? That is the resultant vector moving from O to that point. So let's label the boat moving from, with no current, let's call that OA. And when the boat experiences a current, let's call that AB. We want to determine the resultant, which is OB. So using the triangle law to find OB, so again, with the triangle law, we look to see which two vectors move in the same direction. OA follows AB, and when two vectors follow each other, you add them. So you write OA plus AB. You'll always find the two inner letters are the same, and you add the outer in that order to give us OB. And remember, OB is what you want to find, it's a subject. And therefore you replace OA with negative 1, 2. You replace AB, right, with 3, 0. So when this is AB here, 3, 0. So we put here negative 1, 2. This is 3, 0. And let's work it out. We're going to get negative 1 plus 3, 2 plus 0. We're going to get 2, 2. Which you can now write back in terms of I and j. So this becomes what? 2I plus 2j. Whose answer is A. So if you see this in an exam, it's 2I plus 2j, right? Yeah? Okay, so let's move on to question 25. So 25. We have here Right, pretty straightforward. Two vectors are equal, and this is another common one you see. Two vectors are equal if they have the same magnitude and same direction. They are equal if they have the same magnitude and same direction. So that automatically for 25 is B one time. So let's look at question 26. Right, so we have here vectors again. The position vectors of 2 points A and B relative to an origin O are OA, which is 3, 0, vector OA, whose magnitude is 3, 0, and vector OB, whose magnitude is 8, 5. The modulus of AB and the angle AB makes with the x-axis respectively are. Now with vectors, I'll always advise, if you're given a vector question in your exam, it's always good to have a visual, right? And this is position vectors, so I'll always advise, show a little sketch, so you have some visual, okay? So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. You have, of course, negative 1, negative 2. You have 1, 2, 3. So you have here OA, which is 3, 0. So again, 3 means horizontal movement. We have no vertical. So we're looking at 3, 0, which is here. This is our vector. Right? That's 3, 0. So moving along the x-axis. So this is 3, 0. And OB is what? 8, 5. What 8, 5 means? It means you're moving 8 across and 5 up. So this is 3, 4, 5, right? So we have 3, 4, 5. So you're moving 8 across and 5 upwards. Right? 1, 2, 3 up here. So this is OA. This is A. And this is OB. Alright, that's a vector OA, vector OB, moving in that direction. They want the modulus of AB. Modulus of AB. It means you have to find vector AB first. So you have to find this vector here, AB. So you're moving from A to B. So you want to find that vector first. And after you find that vector, then you can find the modulus of that vector. What's the modulus of vector AB? This is the modulus of vector AB. You put two lines on either side, parallel lines on either side of AB, and you're using your formula, the square root of x squared plus y squared. But first you have to find AB. So let's find AB. Using the triangle law, so remember this is 8, 5 here. We see a triangle, so let's use the triangle law. So I'm going to say what? Vector OA follows vector AB. When two vectors move in the same direction, you add them. So you're going to write OA plus AB. Two and the letters are the same. We'll give you in that order OB. So OB, right? But then you want to find AB. So let's make AB the subject. AB is equal to OB minus OA. OB is 8, 5 minus OA is 3, 0. So when you work that out, you're going to get 8 minus 3 and 5 minus 0. So you're going to get 5, 5. So therefore, if you have to get the modulus of AB, the modulus of AB will be the square root of x squared, x which is 5, squared y which is 5 squared, that's the square root of 25 plus 25, the square root of 50. So the modulus of AB is the square root of 50. So we're looking for the square root of 50. I'm seeing the square root of 50 as my modulus in two options. But then you now want, and the angle AB, this is vector AB, makes with the x-axis. So they want the angle AB makes with the x-axis. So they want this angle here. Got it? So they want that angle. AB makes with the x-axis. So if you have to find an angle between two vectors, then what we're going to do is use what we call a dot product, scalar product, to help us to find the angle between those two vectors. Yeah? And this will be what? Of course, this will be vector. Now the only thing is, when you're finding the angle, the two vectors must move either outwards or inwards. So I'm going to change this to vector AO. Bring this way now. Alright, so you see the two arrows going that way from the fixed point. So I'm going to say AO dot AB is equal to the modulus of AO. So that's how we find the angle using the dot product. Dot the modulus of AB cos theta. AO, remember OA was 3, 0, so AO will be what? Negative 3, 0. So this will be negative 3, 0, dot AB is, that's 5, 5. So, what are we going to get here? This becomes, this is negative 3 by 5 plus 0 by 5 is equal to the modulus of AO, which is the square root of negative 3 squared plus 0 squared, which is 9, dot the modulus of AB squared, which is the square root of 25 squared plus 25 squared, which is square root of 50 cos theta. So we're going to get here, this becomes negative 15 is equal to 3, the square root of 9 is 3, the square root of 50 is the same as the square root of 25 by 2, which is also 5 root 2. So the square root of 25 by 2 is the same as 5 root 2 cos theta. So this becomes negative 15 is equal to 15 root 2 is equal to cos theta. So this becomes negative 15 over 15 root 2 is equal to cos theta, and therefore this becomes negative 1 over the square root of 2 is equal to cos theta. And let's see what that would be equal to. Let's see what that is equal to. Let me see. This will be equal to shift cos of negative 1 divided by square root of 2, close brackets. Right? Now, what has to happen here? We have to, so we want the angle, so we got the modulus, which is 50. Alright, let's leave it as 3, 0. Alright, so we left it as 3, 0, we're going to get positive 15, positive 15, right, we're going to get positive 1, and therefore to get theta by itself, we remove cos, which comes across on the other side as cos inverse of 1 over the square root of 2 is equal to theta. And let's see what we're going to get there. What is cos inverse of 1 all over the square root of 2? So cos inverse, shift cos, open brackets, 1 divided by the square root of 2, close bracket. Right, so we're going to get 45, right? So the angle will be 45, so even though that doesn't look like 45, but 45 degrees, and the modulus is the square root of 50. So this is the modulus here, and this is the angle. Whose answer is for question 26C. Alright? So let's move on to 27. So 27, right, another repeat. So this is a repeat. We would have also done this last night, 27. We have sine x all over 1 minus cos x plus sine x all over 1 plus cos x. So again, to simplify that, we must find the LCM first. The LCM will be 1 of each. 1 minus cos x, 1 plus cos x. So I divide 1 minus cos x into my LCM to give me 1 plus cos x, and I multiply 1 cos plus x by sine x. So I'm going to get sine x into 1 plus cos x plus, let me divide 1 plus cos x into my LCM, I'm going to get 1 minus cos x. So let me multiply sine x by 1 minus cos x. What I can comfortably do now is remove my brackets. So this is sine x by 1 is sine x, and sine x by cos x, this will be plus sine x cos x. And let me remove my second bracket. Plus sine x by 1 is plus sine x, and plus sine x by negative cos x is negative sine x cos x over, I have my denominator, which I will expand. And when I expand that, I'm going to get 1 by 1 is 1, 1 by cos theta is cos theta, or cos x, negative cos x by 1 is negative cos x, and negative cos x by positive cos x is negative cos squared x. So let me simplify both numerator and denominator. So my sine x cos x, those two will cancel out, and sine x plus sine x will give me 2 sine x. And of course, my denominator, I can simplify that. This is cos x minus cos x is 0, so I'm left with 1 minus cos squared x. Now, of course, we want to make sure we get one of the options shown. So 1 minus cos squared x, we have to know identities, is equal to sine squared x. And therefore, I can simplify that by dividing sine x into sine squared x, which gives me sine x. So I'm going to get 2 over sine x. So the answer for question 27 is D, which is a what? That is a repeat. So make sure you pay attention to that, right? So that there is a repeat. So let's look at question 28. So I'm going to erase. So from the time you see that question in the exam, you're looking for 2 over sine x, if you see it. So let's look at 28. Again, I'm going to repeat. I did this just last time, I did this again, this one. All that we just stated as repeat, I would have done last night. So let's look at this here. The figure MON below shows a quarter circle with radius 4 centimeters. The perimeter of the figure in centimeters is. So if you want to find the perimeter, that's the distance around. If it is a quarter circle, it means that the angle at the center of the circle or sector will be 90 degrees. So this is pi over 2 in radians. And therefore, we know that the radius is 4 centimeters. 4 centimeters. What we want to do is determine what's the length of arc, mm. So to find the length of arc, once the angle is in radians, we're going to use, well, first for question 28, we have to get the perimeter. You know it's going to be what? OM plus ON plus MN. MN represents the length of arc. So Mn, the length of arc, is equal to r times theta. R is your radius, which is 4, times theta, which is the sector angle, pi over 2. So 4 by pi over 2 will give us 2 pi. 2 into 2 is 1, 2 into 4 is 2, 2 pi. So we know our length of arc is 2 pi. And therefore, to get the perimeter, we're going to add 2 pi to 4 plus 4, 2 pi plus 8. And to get one of the options shown there, we have to do a bit of factorizing. So I'm going to pull out 2, I'm going to get pi plus 4. So my answer there for 28 will be D. Alright, let's move on to question 29. Right, so 29. Good. So we have the graph for 29. Trigs. The graph of y equal to sine 2x is. So we have to show the graph of y equal to sine 2x. Sine 2x, of course, will be a function where we have two sines. Now, first we need to understand what a sine function, how a sine function looks, right? So a sine function looks like this. If you have, it's always defined between 1 and negative 1. And of course, you have 0, you have 90, you have 180, you have 270, you have 360. But I put it in terms of, let me put it in terms of radians. You have pi over 2 pi, 3 pi over 2 and 2 pi. So your sine curve will look like this. It will look like this. Comes up, turns at 90, cuts at 180, and turns at 270, come up to 360. This is a sine curve which is B. But you don't want y equal to sine x. You want y equal to sine 2x. Which means you must see two sine curves within this period. Two sine curves. Right now this is one sine curve. Sine 2x means you must see two sine curves. How am I going to see two sine curves within my period? So this is what I'm going to do. I'm just going to divide that into 2, 2, 2, 2. So this is what we're going to see. So that's one sine curve within the period. Yeah? And look at the other. And that's the other sine curve within the period. Right? So between 0 and 2 pi, so our answer for this question is C. Alright? So let's move on to 30. So 30, again a repeat. I think I would have done this last night as well too. The smallest positive angle in radians within the range 0 degrees, that's 0 radians, is less than or equal to theta less than 2 pi. That satisfies the equation. So 30, we have 2 cos theta minus 1. And we have cos theta minus 2 is equal to 0. So that is a trig equation. And what we want to do is to find the smallest positive angle that satisfies. Good? But in radians, right? So we will simply say either I'm going to take 2 cos theta minus 1, put it equal to 0. Let me make theta the subject. So this becomes 2 cos theta is equal to 1. Cos theta is a half. And therefore theta is equal to, when I remove cos, and it comes across as cos inverse of a half will give me. Now of course you can convert your calculator into radians, or you can work it in degrees and then convert it into radians. So cos inverse of a half is 60 degrees, right? That's if you look at it in degrees. But then remember they want you to represent it in radians. What is 60 degrees in radians? You know 180 degrees is equal to pi radians. That's the relationship between degrees and radians. 180 degrees is equal to pi radians. 1 degree will be pi over 180, and therefore 60 degrees will be pi over 180 by 60, which will give us what? 60 to 180 pi over 3. So we end up with theta is equal to pi over 3. So we see pi over 3 there, but remember we have another factor, cos theta, or cos theta minus 2 is equal to 0. Cos theta is equal to 2. And theta is equal to, I will bring my cos over as cos inverse. Cos inverse of 2 is undefined. That doesn't exist. That can't work out because cos is defined between 1 and negative 1 when you are drawing your cos function. So therefore anything beyond that will be undefined, can't work out, doesn't exist. So this has no solution. So your answer for theta will be A, yeah? So we're looking at 30A, which is a repeat, okay? So let's look at 31. So 31, we have again another repeat, yeah? So again, I think I would have also done this last night, yeah? So if you see the answer one time, you state what is the answer, not the letter, right? I'm going to shade now, make sure you know what's the answer. So 31, we have cos 5 pi over 12, yeah? So 5 pi over 12 is the same as, that is, because we know pi is 180 degrees, right? If you look to convert that into degrees, so you know what 5 pi over 12 is in degrees. So cos of what that angle is in degrees, that's 5 by 180, which is 900 divided by 12. That's 75 degrees. Good? So we want to find the value of cos 75 degrees, right? Ready? Cos 75 degrees. And what we can do, we can represent 75 degrees into two special angles. So special angles we can state are 45 degrees plus 30 degrees. 45 and 30 are two special angles. And therefore cos of, and of course, 45 plus 30 also represents compound angles. So you know this is the same as cos A plus B, which is cos A cos B minus sine A sine B. You should know that trig, that compound angle expansion formula. So this becomes cos 45 plus 30 degrees will be cos 45 degrees, cos 30 degrees minus sine 45 degrees, sine 30 degrees. Now, you have to know your special angles. Cos 45 degrees is the same as, it's 1 over root 2, but when you rationalize it, it becomes the square root of 2 over 2. Yeah? Cos 30 degrees is the same as the square root of 3 over 2, minus sine 45 degrees is the same as 1 over the square root of 2, but when you rationalize, it becomes the square root of 2 over 2, and sine 30 is a half. So let's simplify this. This becomes the square root of 2 by 3 is the square root of 6, 2 by 2 is 4, subtract, the square root of 2 by 1 is the square root of 2, and 2 by 2 is 4. And therefore what I can do here to simplify to get my answer is to get one of the options shown is to factorize. So I'm going to pull out a quarter, and I divide a quarter into each. A quarter divided into my first term gives me the square root of 6. Subtract, divide a quarter into my second term gives me the square root of 2. So whose answer there for question 31 is B. Alright, that's a repeat. So let's look at 32. 32, So for 32 we have right, another repeat, right? So this is, and again, we did that last night too, in 2022. So again, we can see it in 2023, right? So we have here, they want us to find x. So x is equal to what in what? Radians. So x is equal to 180, subtract 100 plus 60. That's 180, subtract 160, which is 20 degrees, but we have to know to convert degrees to radians using our relationship. 180 degrees is equal to pi radians. 1 degree is pi over 180, and therefore 20 degrees is pi over 180 by 20, which will give us pi over 9 radians. Whose answer for question 32 is B. Alright, let's move on to 33. Alright, so that is a very blurred. So this is for 33, right, that should be sine 2x, sine x. If sine x is equal to x, so if sine x is equal to x, then what is cos 2x? Good? Then what is cos 2x? Good? So cos 2x is a multiple angle, and very important multiple angle. There are 3 representations for cos 2x. So for us to show the option, to find the option shown, note we can use cos 2x is equal to 1 minus 2 sine squared x. So that is one of the identities or representations for cos 2x. And because sine x is equal to x, where I see sine, I'm going to replace it with x. This is 1 minus 2. Sine squared x is really the same as what? X in bracket squared. Yeah? So this becomes what? And x squared is the same as x squared. Yes, it's 1 minus 2 x squared. Yeah? So whose answer is, so 33 is C. So let's move on now to 34. Right, so for 34, if we have what is sine alpha minus 45 degrees, what is that equal to? Again, we're going to use here our compound angle formula, so make sure we know our compound angle formula. So if you have sine A minus B, sine A minus B is the same as sine A cos B minus cos A sine B. So we have to make sure we know that relationship. So you know alpha will be A, 45 will be B. So let's simply expand. This becomes sine alpha minus 45 degrees will be sine alpha cos 45 degrees minus cos alpha sine 45 degrees. Of course, cos 45 and sine 45 both are special angles, and both are 1 over the square root of 2, right? So looking at the options, I'm seeing 1 over the square root of 2. It can also be expressed as the square root of 2 over 2 when you rationalize it. So let's go with 1 over the square root of 2. So this is sine alpha multiplied by 1 over the square root of 2. So I write 1 over the square root of 2 sine alpha minus sine 45 is also 1 over the square root of 2 by cos alpha. So that's 1 over the square root of 2 cos alpha. And what we can do here now is factorize I'm going to pull out 1 over the square root of 2. When I divide it into each, I'm going to get sine alpha minus cos alpha. Yeah? Whose answer for question 34 is E. So question 34 is E. Alright, let's move on to 35. So 35 states what we have here. Right, and this is a repeat. A repeat. Oh, it's very blurred, right? So, but let me state what right on the board what it states. If f of x is equal to sine 3x minus cos 4x, then what is f double prime x? So f double prime x, as we know, is to differentiate a second time, second derivative. So for us to find the second derivative, what we need to do is obviously find the first derivative first, which is f prime x. So f prime x, let's differentiate and be very careful when you're differentiating your trig functions. The differential of sine the angle is cos the angle multiplied by the differential of the angle. Very important part to include. Subtract the differential of cos the angle is minus sine the angle by the differential of the angle. So we're going to get here f prime x. Now this is the first differential, the first derivative. We're going to get the differential of 3x will be what? 3. And I'm going to multiply 3 by cos 3x to give me 3 cos 3x. This will be the differential of 4x is 4. And 4 multiplied by negative sine 4x. Let me write it down, minus negative 4 sine 4x. And of course I can say now a minus by a minus is a plus. So f prime x is 3 cos 3x plus 4 sine 4x. Now that's just f prime x. But they want us to find what? F double prime x, which is the second derivative. So f double prime x, when I differentiate the differential of cos the angle, so I'm going to whole line 3. The differential of cos the angle is negative sine the angle. But don't forget to multiply by, because the chain rule always comes into play. Multiply by the differential of the angle 3x. Now, let me differentiate 4 sine 4x. So I hold my 4 and let me differentiate sine 4x. The differential of sine 4x will be cos 4x multiplied by, using the chain rule, the differential of 4x. So what this becomes? F double prime x will be the differential of 3, x is 3. 3 multiplied by negative sine 3x becomes negative 3 sine 3x. And when I multiply that by 3 outside, it becomes negative 9 sine 3x. And the differential of 4x is 4. 4 multiplied by cos 4x becomes 4 cos 4x. And when I multiply 4 cos 4x by my 4 outside, it becomes plus 16 cos 4x. And that's the second derivative. And let's see whose answer is D, which is a repeat. So you're looking for negative 9 sine 3x plus 16 cos 4x. Certainly a repeat. Alright? So let's look at 36. So 36, another repeat, another repeat, yeah? So we see how many questions are done. These questions I did last night, 2022. So it is highly possible that you're going to see it in your exam tomorrow. So make sure you know the question, you can recognize the question, recognize the answer, of course know how to find it as well. And you simply, give the correct answer if you do see it. So let's look at it. 36. Again, it's blurry, but the curve C has the equation y equal to f of x. C has a stationary point. So the curve is y equal to f of x. It has a stationary point. So the stationary point is negative 2, 5. And if f, but that's supposed to state f double prime, the second derivative is equal to, I think it's x to the power, I think it was x to the power 4 minus 15, then what is the point negative 2, 5 is what? What kind of point it is? Meaning what's the nature of that point? Is it maximum? Is it minimum? Right? So for us to treat with this, all the information is here. We have the second derivative. We know for a stationary point, the differential derivative is 0. We have the stationary point, which is negative 2, 5. And to determine that nature, all we have to do is substitute the x coordinate of that point into the expression for your second derivative. So this becomes negative 2 to the, in brackets, raised to the power of 4 minus 15. Negative 2 to the power of 4 will be 16. And 16 minus 15 will give us 1, which will indicate that the second derivative is greater than 0. And if it is greater than 0, always think of the reverse process. When it's greater than, that will be minimum. So this point, therefore, the point negative 2, 5 is a minimum turning point. Whose answer is C. So it's a minimum turning point. So let's look at 37. Right, so for 37, they want us to differentiate 2x minus 1 over 5 minus x. Okay? So to differentiate that, once we have a quotient, one on top of the other, then we know we divide one by the other, then we know it's the quotient rule. So using the quotient rule where this is u and that is v, the quotient rule is what? Dy over dx is equal to v multiplied by the differential of u minus u multiplied by the differential of v all over v squared. So that's your quotient rule. So let us itemize each. I have u, which is 2x minus 1. I have v, which is 5 minus x. So let me get du over dx, u with respect to x, which is 2, and let me get dv over dx, v with respect to x, and the differential of 5 minus x will give me negative 1. With all my key variables, let me substitute into my quotient rule. Dy over dx will be v, which is 5 minus x, times or dot, which means multiplication, du over dx, which is 2, subtract u, which is 2x minus 1, times dv over dx, which is negative 1. All over v squared, which is 5 minus x, in brackets, all squared. So let us simplify this becomes what? 2x by, let me properly format it. 5 minus x in brackets, I'm going to put my 2 in front, times 2, and this will be negative, of course, negative 1 times 2x minus 1. So this negative 1 by plus, by minus, sorry, becomes plus 1 into 2x minus 1. Alright, so if I put this negative 1 in front, a minus by minus is a plus all over 5 minus x all squared. So when I simplify that, let me simplify the numerator. dy over dx will be 10 minus 2x plus 2x subtract 1 all over 5 minus x all squared. And when I simplify that, clearly negative 2x plus 2x is 0. That cancels out. I'm going to say 10 minus 1 is 9 all over 5 minus x all squared, whose answer for 37 is A. So using the quotient rule, we got that result. So let's move on to 38. Right? So for 38, so I'm erasing all this. So the point 1, 1 lies on that curve. The value of the gradient of the curve is. So we have to find the value of the gradient of the curve. So it means if you have to find the gradient, we must get dy over dx. So we have y, 38. Y is equal to 3x minus 2 all over 2x minus 1. So in order for us to get dy over dx, we have to differentiate that. So we have the quotient, so we're going to use the quotient rule to differentiate it. So we're going to get dy over dx by using the quotient rule. V times du over dx minus v times dv over dx all over v squared. So we have u and we have v. So we know u is equal to 3x minus 2. V is equal to 2x minus 1. So let's get du over dx. Du over dx will be 3. dv over dx will be 2. Let's substitute into our rule. dy over dx will be v, which is 2x subtract 1, times, put my dot, du over dx, which is 3, subtract u, which is 3x minus 2 times dv over dx, which is 2, all over v squared, which is 2x minus 1 in bracket squared. So what are we going to do? This will be dy over dx. I'm going to multiply 3 by everything inside here. I'm going to get 6x minus 3. And this really I'm multiplying negative 2 by everything inside here. So negative 2 by 3x is negative 6x plus 4. So when you bring this 2 in front, when you properly format it, negative 2 by 3x is negative 6x. Negative 2 by negative 2 is plus 4 all over 2x minus 1 all squared. Let's see if we can simplify that further. Yes, we can in numerator. This will be what? These two will cancel out. So you're going to get negative 3 plus 4 will give you 1. So dy over dx will be 1 all over 2x minus 1 in brackets all squared. Now that's just the gradient. But they want us to find the value of the gradient. So to get the value of the gradient, we're going to take the x coordinate of the point P, which is 1, and we're going to substitute that x coordinate into our gradient to get a value for the gradient. So therefore, dy over dx will be 1, 2 into 1, subtract 1, in brackets squared. So we're going to get here, this will give us 1 minus 1, which is 0 squared 2, that's 1. Let me just double check here. So we have v, so u is 3x minus 2, v is 2x minus 1, du over dx is 3, dv over dx is 2. We're going to get dy over dx v, which is 2x minus 1, times du over dx, which is 3, subtract u, which is 3x minus 2, times dv over dx, which is 2. We're going to get here 6x minus 3, and this will be negative 2, we're going to get 6x plus 4 all over 2x minus 1 all squared, and yeah, b is 2x minus 1 all squared, and therefore when we substitute x as 1, we're going to get 2, right, yes, so this becomes 1 all over, so just double check it, we're going to get 2 minus 1 all squared, which becomes 1 over 1, which is 1, yeah? So let's double check it to make sure that our substitution, everything is right. So therefore we're going to get 1 as our answer, which is E. So question 38 is E. Let's look at 39. So 39. Given that y is equal to 2x squared plus 3 sine x, then dy over dx is what? So for 39, we have y is equal to 2x squared plus 3 sine x. So you want to differentiate that. So let's differentiate that to see what's going to happen. So dy over dx, the differential of 2x squared will give us what? 4x. And the differential of 3 sine x will give us what? This will be plus 3. The differential of sine the angle will be cos the angle. Alright? And therefore, that will be our answer, which is 4x plus 3 cos x, whose answer is D. Let's look at question 40. Question 40, we have here, if the integral between 1 and 4 of f of x dx is equal to 6, then what is the integral between 1 and 4 of 4 f of x dx plus 5? What is that equal to? Now, we can, this integral between the limits 1 and 4 f of x dx, we can rewrite that as, we can take this 4, we can put it in front of the integral, plus 5, so we can rewrite it like that, and we know that for the integral between the limits 1 and 4 f of x dx is what? That is what? 6. So this is the same as saying 4 times 6 plus 5, that's 24 plus 5, which is 29. So for question 40, the answer is C. Alright? Let's look at 41. So 41. Right, and this is a repeat. So you repeat again. So if you see the answer, you simply shade the answer, right? So what is the answer for this one? So the region R is enclosed by the x-axis. The curve y is equal to negative x squared plus 2. And the lines x equal to 0 and x equal to 1. What is the area of the region R? So, if you have, let's assume, so of course the function is negative x squared plus 2. And I'm going to just assume that this is our function. Let's assume. Alright? This is the function y is equal to negative x squared plus 2. And they want us to find the area of the region R which exists between the curve y equal to negative x squared plus 2, the lines x equal to 0, which is the y-axis, that's the line x equal to 0, x equal to 1, that vertical line passing through 1 on the x-axis, right? So of course I know x-axis. So So we're looking at this region here. So we're looking at the region between the curve, the x-axis, and the lines x equal to 0, x equal to 1. So that's a region. So to find the area under the curve within a given limit, we use the formula area is the integral between the limits a and b, a being the lower limit, b being the upper limit, y dx. So this becomes a is equal to the integral between 0 and 1, y is negative x squared plus 2 dx. So let us integrate that and substitute our limits to see what we're going to get as the area of that region I have shaded in red. So this becomes a is equal to negative x cubed all over 3. We add 1 to the power, divide by the new power, plus the integral of 2 is 2x between my limits 0 and 1, which must always be maintained. So this becomes a is equal to negative 1 in brackets cube all over 3 plus 2 times 1 subtract. If I replace x with 0, everything, of course, when I substitute 0 into my expression there, obviously I'm going to get 0. Right, so we should check to ensure it's 0, and therefore this will become a is equal to 1 cube is 1, then we consider the negative sign in front of it, so it becomes negative a third plus 2. And negative a third plus 2 is the same as 6 all over 3, so that becomes 5 all over 3. So my answer for question 41, which is a repeat, is B. Okay? Let's look at question 42. So 42, right, so we have the integral of 2x minus 4 cube dx. Good? So if you have to integrate that function is a composite function. And if you have to integrate a composite function, what do? We are going to, obviously, once we start integrating, we drop the integral symbol dx. We're going to add 1 to our power. We're going to divide by the new power. So we add 1 to 3, which is 4, divide by 4, multiplied by 1 all over the differential of what is in brackets, 1 over the differential of what's in brackets, plus your constant c. So this becomes 2x minus 4 all to the power of 4 over 4 times 1 all over the differential of 2x minus 4 will give me 2 plus c. And what I can do now is multiply my numerator by my numerator. So I'm going to get 2x minus 4 to the power of 4 all over. I can multiply my denominator by my denominator. 4 by 2 is 8 plus c, whose answer is that answer should be D, right? There should be an 8 here, right? But it is 8 here. That is D. So remember, it's a bit blurred, very blurred. So, but that's the best paper I could have gotten for 2020. And this is an important paper to do, right? So let's look at 43. So we see where there are a number of repeats, 2020, 2022, a number of repeats. So let's look at 43. Right, so the region bounded by the curve y equal to 2 sine x, the x-axis, and the lines x equal to 0 and x equal to pi is revolved about the x-axis to form a solid of revolution. the volume of the solid generated can be found from. So what we're dealing with, volume of revolution here. So we have, let's assume that this here is our, and let's assuming this is our function 2 sine x. Just assume, right? And they want us to find the region, the volume of the region bounded by the curve y equal to 2 sine x. The x-axis, the lines x equal to 0, which is your y-axis, and x equal to pi. So we assume that this here is pi. Good? They want me to find the volume of revolution. So if I take my x-axis and use it as a spindle, for example, like the jack of a car, and you start to spin or rotate that x-axis, that shape will revolve, and therefore it looks like a solid. Yeah? So to find the volume of a solid, we are going to simply use the formula pi integral between the limits a and b y squared dx. So the volume of a solid with respect to the x-axis. That's the formula we're going to use. So this becomes v is equal to pi. Your limits will be 0 and pi. But y squared, y is what? 2 sine x. So this becomes 2 sine x all squared dx. So when I square that, that's 2 sine x by 2 sine x. This becomes v is equal to pi, limit 0 and pi. And 2 sine x by 2 sine x is 2 by 2 is 4. And sine x by sine x will be sine squared x, not sine squared x squared. Huh? Some students write sine squared x. Good? Dx. So that is what I have to integrate to help me to get my result. Yeah? Whose answer for that is A. So 43 is A. So let's look at 44. So 44 we have, right, if y is equal to 3x squared plus cos x, they want us to find the integral of that function. The integral of 3x squared plus cos x dx. What is that equal to? So of course if we have to integrate, we're going to integrate our first term. So when we start integrating, you drop your integral symbol and dx, you add 1 to the power, you divide by the new power, yeah, plus, let me integrate cos the angle, yeah, so the integral of cos the angle will be sine the angle, but we must remember to add c. So therefore when we simplify, 3x squared over 3 becomes 3x cubed, over 3, it becomes x cubed plus sine x plus c, whose answer is B. So making sure we can integrate and we can differentiate. You know you're going to see that in the latter part of the paper tomorrow. And 45. Right, what is the integral of cos x minus 2 sine x dx? So again, we want to integrate that. So we drop our integral symbol and dx, and let's integrate. The integral of cos the angle will be sine the angle, and let's integrate 2 sine x. Of course, I hold my negative 2. And the integral of sine the angle is negative cos the angle. plus C. Yeah? So sine x will give us negative cos x. Yeah? Plus C. And therefore this will simplify to become sine x. Negative 2 by negative cos x is plus 2 cos x plus C. So the answer there will be sine x plus 2 cos x plus C, whose answer is D. 45D. Alright? So this brings us to the end of this paper. I'm also going to end it right now, right? But I wish everyone all the best in your exam tomorrow. Remember, a number of the questions will be repeated. They would have included now a bit of probability in the question, so make sure that you know your probability, and you can treat with questions involving probability and statistics. Good, make sure you are familiar with those two. You're going to see that in the latter part, very latter part of the exam. Again, don't forget the must pass Moyo Math course, right? That will take place on Saturday, and the information will be shared by tomorrow. Okay, so wishing everyone all the best in the exam tomorrow, and I know you are all going to do well. So, with that said, have a great night, and I'll see you all. Take care.